So this general atmospheric circulation, it's a term which is also used, technically it is also known as tricellular meridional circulation. Tricellular meridional circulation. Tricellular is three cells, right? Three cells. Meridional is along the meridian, so along a longitude or latitude. Right? So along a longitude. So tricellular, three cells along a longitude circulation, right? Tricellular meridian. Now we have already seen this partly, right? But we'll cover this again. Tricellular meridional circulation. So if I draw half of the earth like this, right? And then I draw the equator here, center. I draw the subtropical high pressure belt. I draw the subpolar low pressure belt, and this is the polar high, right? In the northern hemisphere. In the southern hemisphere, similarly, subtropical high pressure belt, subpolar low pressure belt, and the polar high, right? Now, on the surface of the planet, what is the wind? The primary winds we have discussed. We'll see the primary winds. What are the primary winds? Trades, westerlies, polar easterlies. Again, trades, westerlies, polar easterlies. Right? This is surface circulation over the surface of the earth. What is happening here? The trades converge and move vertically upwards. That is why we have equatorial low pressure belt. So here, winds go up. We have discussed that once they go up, they diverge, right? And they are deflected towards the poles because of the curvature and the rotation. So deflection towards poles. Then there is descending wind, right? The winds descend down. So giving rise to subtropical high pressure belt. The trade winds, this arrow, same, the trade winds coming back, complete the circle. This is the first cell, tricellular. This is the first cell. This is called Hadley cell. The Hadley cell, right? This is called the Hadley cell. Second, now on surface you have westerlies. You know the westerlies are uplifted at the subpolar low pressure belt by the polar easterlies. The westerlies are uplifted, so you get this wind going up, and it diverges again like this. Diverges again. Second cell is completed, right? So here there will be uplifting and then divergence. So the second cell here is completed. This is the first cell. This is the second cell. Second cell is completed. This is called Ferrel cell. Ferrel's cell. So the second cell. Ferrel cell. And third is, this is brought down on the poles, right? On the surface, the same arrows, you get this polar easterlies. This is the third cell, the polar cell. It is the polar cell. Clear? So this is the tricellular meridional circulation. This is the upper atmosphere circulation, which includes the Hadley cell, Ferrel cell, and polar cell. Now, understand one thing. I told you India has been an exceptional land. Why? Because we were part of Gondwana. We broke up from Gondwana and came and joined Eurasia, the Laurasia portion or Angara land. Similarly, the classification of winds that we have discussed now, we have discussed planetary winds, invariable winds, right, which blow throughout the globe in their particular zone throughout the year, 24/7. There is no change in it. But again, India is exceptional. Monsoon is the reversal of Hadley. Monsoon is the monsoon that we are experiencing now. It is reversal of Hadley. How? Northeast trades. But what is the direction now in India? Tropics mein? Which monsoon do we have? Huh? Yeah. So what is the direction of monsoon winds in India? Southwest to northeast. So it is exactly opposite this. This is northeast to southwest. We are in the same zone, but the direction is exactly opposite. So in India, during monsoon, what happens? I'm just drawing a parallel diagram here. What happens during monsoon? Southwest to northeast. Right? That is the monsoon. There is upliftment of winds from Tibet. The winds come back to Indian Ocean as a jet stream that is called tropical easterly jet, Tej. We're going to see that when we discuss monsoon. The tropical easterly jet. It comes back and then there is descending wind over the Indian Ocean. Now look at every arrow here and every arrow here. It's complete opposite. So in India, for this 3 to 4 months, there is complete reversal of the Hadley cell. We completely reverse the Hadley cell. वो पहला सेल पूरा चेंज हो जाता है इंडिया में, बाकी हर जगह it is constant. That is why again Indian climate is exceptional, right? We have got this. We reverse the Hadley for 3 months, and we get southwest monsoon. Right? Once the monsoon is over and the retreating monsoon begins, the Hadley is broken down. This reversal is broken down, and again the Hadley cell is reestablished. So you get northeast trade winds, dry climate, dry weather, winter. Clear? Any doubt? समझ में आया? Tricellular meridional circulation, reversal of Hadley as monsoon. Why does this happen? So you're asking me why we get monsoon type of climate? Why only in India? The geography of India is such that this is what happens because of the Himalayas. See, practically speaking, India is a country which is divided into two parts, tropical and temperate, because the Tropic of Cancer passes through center. So half of India is tropical, the peninsular part, and the northern part is supposed to be temperate, which is supposed to have a milder climate. But the problem is, for all practical purposes, the whole of India becomes tropical because of the presence of Himalayas. If there was no Himalayas, I told you, we'll have much milder climate in the north, right? We can have much milder climate in the north, more harsher climate in the north. But because of presence of Himalayas, the whole India becomes tropical. So that leads to intensive hitting during the summer season. That brings the monsoon, the ITCZ, the convergence between two trade winds completely shifts northward, resulting into a very distinct type of climate that we experience as monsoon. We're going to see the origin and mechanism of monsoon. That time you will understand why this happens here and not anywhere else. Yes? Any doubt here? Okay. So this is general atmospheric circulation. The three cells and the reversal during monsoon, Hadley. So Ferrel cell, the Hadley cell, Ferrel cell and polar cell, that is same here on the opposite side, the whole thing, right? Across the globe.